dear all, good morning everyone. Today I am going to teach MERS art. I am Achintya Pandey, Assistant Professor in Department of Information Technology at Ajay Kumar Garg Engineering College, Ghaziabad. Okay. So, what is MERS art? We will, in MERS art, the objective is to explore the implementation, testing and performance of MERS art algorithm. See, we will discuss MERS sort in two ways, right? You will never forget if you remember the process MERS sort, I assure you. First, we will simply discuss how MERS sort will be. Then we will adopt another approach which is based on divide and conquer approach. So let's see with the simplest approach how we sort using MERS sort. Okay. Okay. So to understand merge sort, we would require how to merge two sorted array into another array to get the resultant sorted array elements. Okay. So first, what is sorting? You all will be knowing sorting means arrangement of element in a particular order. In general, we arrange the element into increasing order, right? We can even sort into decreasing order, but here or the general method is to sort element into increasing order. So let's see the algorithm. First, we would be required merging operation. So let's see how merging operation occurs. Okay. First, let's see the algorithm. Then we will discuss example so that one can easily sort. Right. So what is merging operation? Merging operation means we have two sorted array. Okay, two sorted array means elements are already in increasing order in both array. The resultant array will be sorted list of both two array. Okay, so how we do? How we sort two sorted array so that the resultant array will be sorted. So let's see the algorithm. The merging operation will be required. So what is the merging operation? See, suppose A and B are two sorted array having R and S element respectively. This algorithm merges A and B into an array C with n equal to R plus S element. So see, A is the first array, B is the second array. What is R? R is the number of element in A and S is the number of element in B. C is the resultant array which we want to be sorted finally. So what are the steps? First we will initialize. So we have say some indexes. Suppose we start the array with first element. We will what we do in merging, we actually compare elements. How we compare? The first element of array A will be compared with the first element of array B, and which one will be sorted, I mean which one will be lesser, we will put into the C. Clear? First element of array A will be compared with the first element of B, and the element which will be less will put into C. Again, the same process will be adopted. So see the process. What are the process? First we initialize NA equal to 1 just for marking the first element of array. So we put NA equal to 1. Similarly, suppose this is the array A, means first array which will have some element. Okay, and these elements are sorted, say 3, 4, 9, 10 and 12. This is suppose A. Okay. Similarly, suppose B is like this, again some sorted array, say 1, say 19, say 3, say 5, like this, and so on. So what will we do? This is the B. We initialize, this is the NA, and this is the NB. Starting say like 1, 2, this is the serial number, okay, 1, 2, 3, 4, 5, like this, okay. Sorry. Okay. So what the algorithm say? First we initialize NA equal to 1. This is the NA. This is the NB. NB becomes 1. And there will be another, I mean, resultant array which we want the sorted element of both. I mean, like 1, 3, 4, and like this. So this is the C. For this we have assigned PTR if it starts from 1, 2, 3, 4 and like this, okay, 5 and all. So this variable is PTR, okay. So we initialize NA equal to 1, NB equal to 1 and PTR equal to 1 in the starting. Now what we will compare? We will compare the first element of A with the first element of B, and the value which will be less will be put into the C array, okay. So see, in this example, I just compare with the algorithm. If ANA is less than BNB, means ANA, what will be the ANA? Means here 3, value at first element of array A. And index will be the value, right? NA is basically index, NB is basically index, and PTR is the index, like which start from 1, 2, 3, 4. So what we will do? We have initialized the value of NA, NB and PTR. What will repeat? Repeat while NA less than, means जब तक ये लिस्ट जो है, I mean NA जब तक ये लिस्ट एंड ना हो जाए तब तक क्या होगा? A को हम रिपीट करेंगे, I mean इंक्रीमेंट करते रहेंगे. So repeat while NA less than or equal to R and NB less than or equal to S, means जब तक कोई पर्टिकुलर एक लिस्ट एंड ना हो जाए, क्या करना है? What we do? If ANA is less than BNB, means the first value of this array, if it is less than the first value of B array, right? Then what we will do? We will assign the lesser number into this. For example, in this array A and B, which one is less? ANA means 3 is not less than BNB means 1. So what we will do? We will assign BNB, means the value which is lesser, we will be assigning to the resultant array C, okay. So out of this, this will be assigned here, right? So what we do? यदि सपोज ये वैल्यू कम होता है इससे, तो ये वाली वैल्यू इसमें आ जाएगी और पॉइंटर ये क्या हो जाए? इधर बढ़ जाएगा. अब ये क्या हो गया कि अब ये पॉइंटर कहां बढ़ जाएगा? यहां पे बढ़ेगा, ठीक है. ये वैल्यू ये खत्म हो गया. Clear? So we will compare individual element, I mean start with the first element, okay, and the value which will be lesser than we will put into the resultant array C. So we will do like this. So assign element from A to C if ANA less than B or if A and B less than B and B, else part में क्या हो जाएगा? इसका reverse, means this one will be greater, not lesser. So if this one will be greater, means this one will be smaller. So we assign C PTR equal to B and B, and PTR will be in starting what we have initialized into PTR 1. Clear? So by this I mean step, we assign value which is lesser out of this array into this resultant array, and again we increment, I mean NA and NB, which one will be lesser, pointer will move in that direction, right? Now if the list exhausts, for example if NA is greater than say 5, means number of element in A, means the remaining element will be in B. This will be simply appended into this resultant array. So for that, what is the algorithm? Assign remaining element into C, यानी यदि कोई भी जो भी लिस्ट पहले एग्जॉस्ट हो जाएगा, एग्जॉस्ट का मतलब कंपेयर करते चले हम, और जो छोटा होगा उसको इसमें हम रखते जा रहे हैं. ओके, सो आउट ऑफ ए एंड बी कोई भी एक लिस्ट पहले क्या हो जाएगी, एग्जॉस्ट हो जाएगी, मतलब एलिमेंट सारे कॉपीड हो जाएंगे जो छोटा होगा. उसके बाद ऑलरेडी जो बचा हुआ एरे होगा से ए आर बी, उसके रिमेनिंग एलिमेंट को हम ऑलरेडी यहाँ पे अपेंड कर देंगे क्योंकि वो ऑलरेडी सॉर्टेड है. इज दैट ओके? सो this step we are doing, assign remaining element to C by increasing, say every time NA and NB are increasing because depending on which one is lesser. If the value in A will be lesser as comparison to B, then the NA will be incremented. If the value in B will be lesser, I mean corresponding value will be lesser, then NB will be incremented. So if NA reach to the last, I mean index of this array, okay, so this will be I mean backend, and the remaining element of B will be simply appended into this array. Okay, so for this, if NA greater than R means A खत्म हो गया है, A के सारे एलिमेंट क्या हो गए, खत्म हो गए हैं, तो B के जो बचे हुए एलिमेंट है वो C में हम रख देंगे. किस हिसाब से? लाइक दिस, रिपीट फॉर K इक्वल टू 0 1 S minus NB, C PTR plus K equal to B NB plus K, or we will put A, remaining element of A. If B is, I mean B is यदि B पहले खत्म हो जा रहा है, ठीक है, सो हम A के बचे हुए जो एलिमेंट है उसको C में रख देंगे. राइट? सो दिस इज द सिंपल वे to merge sort. We would be require merging operations, and merging operation means we are going to sort two sorted array into a resultant, I mean array C. So this is the simple way. Let's see with the example again. Suppose how you can solve the example. Just see, we have array A like element 22, 44, 55, 77, 88, and second array is B, say value 33, 66 and 70. So what we will do? We just apply the algorithm. This is A, we will initialize NA equal to 1, then NB equal to, here this is NB equal to 1, we start with this. So the value which will be lesser will be put into the resultant array. So this is the sorted array. We will compare first element with the first element of B. Which one is lesser? 22. So we will put this 22 into the array C. Okay, then we will have this much element. In A, we will have this element, and B we will have again. So NA will be incremented, but NB will be same. NA will be incremented, right? So again we will compare the corresponding element. Which one will lesser? 44 and 33. Which one will lesser? So 33 is lesser. So we will put 33 into the C array, and the resultant array will be like this. Two element has been sorted. Same process we will apply. The remaining element of A will be as such, because, and B will be this. Again, which one will lesser? 44. 44 यहाँ आ गया. Again apply the same. Which one will be lesser? 55 and 66. So 55 यहाँ आ गया. And after that the array will be 77, 88 and 66, 70. So which one will lesser? Out of this 66. So this will come here, and so on. So we will get this resultant sorted array. So this is not merging sorting. In merge sort, merging operation will be required. So how we perform merge sort? Let's see. So what we do in the merge sort? just let's discuss with the again example. So we will use merging operation to sort. So what we do, suppose if the list are given, suppose we have 14 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14 elements. Now we want to sort all these elements into sorted, we have to rearrange these elements into increasing order by using merge sort operation. So how we do? How we use the merging operation? So what we do, first we make pair of elements, right? Suppose this is even number, so we will start pairing like 66, 33, 40, 22, 55, 88, 60 and this we will make pair. Suppose if it is even, then we will we can make pair easily. If it is suppose odd number, then there will be a single element at last, right? So there is no issue, even, odd or even. So first we do pairing of each element, okay? We start pairing. Now each pass of the merge sort algorithm will start at the beginning of the array A and merge pairs of sorted array. So we have made, this is the array and we will sort these elements, comparatively we will sort these elements, okay? So merge each pair of element to obtain list of sorted pair. तो पास वन में हम क्या करेंगे, merge each pair of element to obtain list of sorted pair, okay? अब इनको हम क्या करेंगे, इंडिविजुअली इनको सॉर्ट करेंगे. लाइक ये सपोज ये 2 एलिमेंट है, जब हम पेयर किए हैं तो अब इनमें हम क्या करेंगे, इनकी सॉर्टिंग कर देंगे. 2 एलिमेंट में सॉर्टिंग कर से विच वन विल लेसर विल बी कम फर्स्ट. सो 66 and 33 how will sort? This is the second element is lesser, so we will swap 33, 66. Again here we will swap because 22 is lesser, so it will come first, like this, like this. So in pass 1 we have created a sorted array of 2 elements, okay? Now what we do, so we have one sorted array, we have again second sorted array and so on. So we have a list of sorted array of 2 elements each, okay? So again we apply the merging operation on these like this, because in merging operation what we require, there must be sorted array, then we can merge and the resultant array should sorted. So as we have seen in the merging operation, what we do, we compare first element of array A with the first element of array B and the value which will be lesser will put into the array C. So just apply the merging operations. So 33 and 22, which one will be lesser? 22 is lesser, so we will put this 22 into resultant array C, okay, and the NB will be 2. This pointer will move at the second element. Again we will compare 40 and 33. So which one will lesser? 33, okay. So B exhaust हो गया, so बाकी remaining जो element है हम आगे रख देंगे, ठीक है. Sorry, second element we will compare 40 and 33. Which one will lesser? 33. तो 33 आ जाएगा, okay. Just then we would have 40 and 66. Which one will lesser? 40, okay. And 22, 33, 40, and this is not 60, this will be 66. ये wrongly जो है लिख दिया गया, यहाँ पे क्या होगा, 60 ना होकर क्या होगा, 66 होगा, okay. Again we will compare this two sorted array, okay, and the resultant array will be, means we will merge each pair of pairs to obtain list of sorted quadruples, okay. So out of the, if we sort corresponding element, so we will get this list, right. Just compare first element with this first element, the value which will be lesser will put into the resultant array here. Again, we will compare 6 and 55. Which one will be lesser? 55 we will put into this. This this list has been finished. 60 we have 60. We will put here. Then 88 means what we do? We just compare the corresponding element, right? And the value which will be lesser will put into the resultant array. So by this way we get this list. Again we apply the same and we get this list. Since there is no pairing, so this will be as such. Now we pair this quadruple. So merge each pair of sorted quadruple to obtain the two sorted subarray. Okay. So we again sort this element, means compare first element with this first element. The value which will be lesser will be put into the first element of resultant. So here we will put. Again we will compare second element with this list. So which one will be lesser? 22. So we put 22 and so on. So we get the resultant sorted subarray and this will be. Similarly here, what we do? We compare first element of this sorted list with this first element of which one will lesser? 20. So we will put 20 here. Then again we will compare 30 with 44. Which one will lesser? 30. So this will come into second position. And 44 will be compared with 77. 44 is lesser. So third and so. So finally we get two sorted subarray and that sorted subarray is sorted subarray. So we can again apply the merging and the resultant will be the sorted list. So by this way we do merge sort. So guys, you understand this? Just a quick revision. We have given a list. What we do? We just compare first element. First we start making pairing of elements. Means दो एलिमेंट का हम क्या करेंगे? पेयर करेंगे. ठीक. उसके बाद से क्या करेंगे? दो एलिमेंट को हम शॉर्ट कर सकते हैं. जो वैल्यूलेस होगा पहले होगा. Okay. So we get a sorted array of two elements. So we will have n sorted array. Okay. Now we make a group of two sorted subarray. Okay. And finally we get two sorted subarray and we will apply merging operations and the list will be get sorted. Okay. So what we do? We just comparing first element with the first element of second list and the value which will be lesser we are just putting into the resultant array and by this way we can sort. So this is what we do in merge sort, right? Now merge sort can be solved by divide and conquer approach. Means now we are going to use recursion based concept. What is recursion? Recursion means something if you define in terms of itself then become recursion. In the function we make recursive function just to solve n type ka, problem, right? So the algorithm will be divide and conquer means what? A large program is divided into sub program. That is the approach. Means बड़ा डेटा है उसको छोटे डेटा में, छोटा डेटा है अगेन उसको छोटा डेटा में, एंड लास्ट में हम उनको जैसे जैसे सपोज एग्जॉस्ट हो जाएगा सो ऑलरेडी वो परफॉर्म हो जाएगा. So what we do? Just see the merge sort using divide and conquer approach. So this is the algorithm: divide, conquer and combine. So suppose we have an array A which is start from P and R, means the index is start from first element क्या है? P है. P is not element, P is basically index. Suppose कोई भी random है, suppose मान लो ये आपका array है, it's P is what? P is any position. Suppose this is the array In C we start from 0, 1, 2, 3, 4, right? Like this. So P can be anywhere. Suppose P could be from 2, P could be say 5, and R is the last. P could be 0 and like this. Okay. So just see the algorithm. Suppose we are going to sort an array from P to R, means we are going to sort the element from AP to up to AR. So what we do? As the approach is divide and conquer, means we will divide the list into two sublists. Again, we will pick the one sublist, we divide into say 2, and that sublist again divided into 2, and in this way we will solve the problem of sorting, and that sorting is merge sort. So what we do? See, divide the n element sequence to be sorted into two subsequences of n by 2 element each. Means exactly 2 half में हम list को क्या कर रहे हैं? Divide करने जा रहे हैं. Conquer sort the subsequences recursively using the merge sort when the size of the sequences is 1. There is nothing more to do. And merge the two sorted subsequences. Let's see the example. By that you can understand easily. Suppose this is the element 5, 2, 4, 7, 1, 3, 2, 6. Okay. Suppose it start from 1, 2, 3. So P is 1, starting index. R is 8. In this example, this array start from 1, means P की value कितनी है? 1, and R की value कितनी है? 8. So we are going to sort these lists using merge sort, and which is based on the divide and conquer approach. So what we do? Means here we are going to implement recursion. Problem could be solved in its own way. Means merge sort will be defined in terms of merge sort, right? So this is the function, say merge sort. This is the name of array. This is the name of array. This is the index, beginning index, and this is the last. Okay, like here P is 1. In this example, P is 1, R is 8. Means we have 8 element. We are going to solve using merge sort, and the approach should be divide and conquer. So what we do? First, if P means index, if P is less than R, here 1 is less than 8, yes, it is true. Then what we do? We find the mid element, Q. Q will be P plus R divided by 2. And we have used the floor function. So what we get? Q in this example, 1 plus 8, 1 plus 8 divided by 2 means 9 by 2 means 4.5, and the integer value will be, when we apply the floor function, 1 plus 8, 9 by 2 means 4. So Q becomes 4. Okay. So Q is now 4. Now we again call this function merge sort APQ. Means what? Here A is array, P is say 1 and 8. R is 8. Now here when we break, find the mid element, like Q equal to P plus R divided by 2 means 4. Then again we call this same function merge sort. Okay, यानी कि ये function अपने आप को ही कॉल कर रहा है. तो ये लाइन एग्जीक्यूट होगा ए पी क्यू. तो आर पी तो पी है, पी कितना रहेगा? 1 ही रहेगा. क्यू क्या हो गया? आर की वैल्यू अब क्या हो जाएगी? क्यू हो जाएगी. और क्यू क्या हो गया? 4. तो A14 ये फंक्शन कॉल हुआ. जब ये फंक्शन कॉल हुआ तो अगेन ये क्या करेगा? इसको फिर कॉल करेगा. कंट्रोल अगेन goes from starting, and we will find Q. So what will be Q now? 1 plus 4 divided by 2 means 5 by 2 means 2.5, and we will apply this floor function. तो क्या हो जाएगा? 2 हो जाएगा. Okay. Okay. Then again we will have कब तक करेंगे? जब तक P लेस देन R, राइट। मीन्स एक एक लिस्ट को हम क्या कर रहे हैं, जो सपोज लेफ्ट सब लिस्ट है उसको सॉर्टेड करेंगे, और जब ये सेटिस्फाइड नहीं होगा तो ये हम बाहर आ जाएगा, और बाहर आने के बाद फिर क्या करें, बचा हुआ जो रिमेनिंग हाफ है उसको फिर क्या करेंगे, हम अप्लाई करेंगे। ये फंक्शन फिर से कॉल करेगा, यानी यहां से यहां वाला अब हो जाएगा। अब P की वैल्यू क्या हो चुकी है इसके लिए, Q+1 एंड R अगेन 8 ही रहेगा, ठीक है। तो यानी कि ये लिस्ट पूरा सॉर्ट हो जाएगा, देन एंड ओनली अगेन ये कॉल करेगा, ठीक है। एग्जांपल से आपको बढ़िया समझ में आएगा। तो देखिए मर्ज सॉर्ट ने मर्ज सॉर्ट को ही कॉल किया, ठीक, यानी सेम फंक्शन इज फर्दर डिवाइडेड, ओके। बस उसका इनपुट साइज क्या हो रहा है, जो साइज है P और R की वैल्यू ये जो है डिक्रीमेंट हो रहा है, ठीक। मींस लिस्ट क्या हो रहा है, शॉर्टर हो रहा है, ओके। एंड उसके बाद से जब ये हम क्या कर देंगे, जब इसके बाहर आ जाएंगे तो हम क्या कर देंगे, मर्ज ऑपरेशन परफॉर्म करेंगे। एग्जांपल से आपको ज्यादा समझ में आएगा। जैसे कि ये है आपका, सपोज ये लिस्ट है, तो सबसे पहले क्या किया, मर्ज सॉर्ट APQ यानी 1-4 में, यानी कि एक लिस्ट ये हो जाएगा और दूसरा लिस्ट क्या बनेगा 1-3-2-6, ओके, लाइक दिस 5-2-4-7 1-3-2-6। so P is what, P is 1, this is the P beginning and this is the R, this is P, this is R. P is 1, R is 8, Q will be 1 plus 8 divided by 1 plus 8 divided by 2 means 9 by 2 means 4, okay. So Q becomes 4, okay. So means we have divided this list into two half, 5-2-4-7 and 1-3-2-6, so like this. So this one will be, and this is there. So this further list will be divided. So here P is 1, R is 4, okay. So Q will be 1 plus R divided by 2, 1 plus 4 divided by 2, यानी 5 by 2 means 2.5 means 2. So this is, so 5-2 एक सब लिस्ट हो जाएगा, और ये दूसरा वाला क्या हो जाएगा 4-7। फर्दर इसमें आप क्या करेंगे, Q निकालेंगे, Q will be 1 plus 2 divided by 1 plus 2 divided by 2 means 1 plus 2 3, 3 by 2 1.5 means 1. So अब यहाँ पे Q क्या आ जाएगा, 1 आ जाएगा, ओके। So P is not less than, ये वाला कंडीशन नहीं सेटिस्फाइड होगा, P is not less than R, P is equal to R। इसका मतलब क्या है, इसके हम बाहर आ जाएंगे, ठीक। तो जब यहां पर ब्रेक होगा तो P is not less than R, तो इसलिए हम इसको हम ब्रेक कर सकते हैं लाइक दिस, दूसरा, ओके, एंड सो ऑन। सिमिलरली इस लिस्ट के लिए भी ऐसे ही करेंगे, P यहां पे आ जाएगा और R ये हो जाएगा। Q जब आप निकालेंगे 5 plus 8 डिवाइड बाई 2, 8 plus 5 13 by 2 मीन्स 6.5 मीन्स 6। सो 1-3 एक सब लिस्ट हो जाएगा, ये 2-6 दूसरे वाले हो जाएंगे। फिर इसको हम क्या करेंगे, डिवाइड करेंगे। सो जब आप डिवाइड करेंगे तो क्या होगा 1 and 3, राइट। तो एक पूरी जो n लिस्ट है, लास्ट में हम एक एक एलिमेंट में क्या कर दिए, ब्रेक कर दिए। और जब एक एक एलिमेंट में आप ब्रेक कर दिए, देन अब क्या करेंगे, इसको हम बॉटम अप अप्रोच से सिंथेसाइज करेंगे एंड इंडिविजुअली हम इसको सॉर्ट करते चलेंगे, ओके। मर्ज ऑपरेशन, वहां भी हमने क्या लिखा है लास्ट में, मर्ज। मर्ज अभी आपको बताया, मर्ज में हम क्या करते हैं, देयर मस्ट बी सॉर्टेड एरे, ओके, एंड वी सॉर्ट, देयर मस्ट बी 2 sorted array and the resultant array should be sorted array. So what we do, we compare the first element of say one sorted array with the first element of second sorted array, and the value which will be lesser will be putting into the resultant. So this is called bottom up approach. So जैसे ये 5 and 2 है, इसमें कौन सा सॉर्टेड होगा, 2 and 5, तो 2 and 5 का क्या बन जाएगा, सॉर्टेड बन जाएगा। उसको अगले नेक्स्ट स्टेप में हम देख लेंगे। ये देखिए, दिस इज द बॉटम अप अप्रोच, वी आर मूविंग लाइक इन दिस डायरेक्शंस। वी हैव डिवाइडेड n element into finally one element. So we have list, and then what we do, we start making pairing, okay. So 5 and 2 we will start pairing, Okay, so which will be lesser? 2. So we have made a sorted subarray of 2 elements. Again here 4 and 7. This is already sorted like this. So we have now sorted array of size 2. 1, 2, 3, 4. Okay, 2, 5, 4, 7. ये भी इंडिविजुअली ये क्या है? सॉर्टेड है. फिर इसको हम क्या करेंगे? सॉर्ट करेंगे. कौन सा एल्गोरिथम लगाएंगे? मर्जिंग. एंड मर्जिंग में क्या करेंगे? इंडिविजुअल एलिमेंट्स को हम क्या करेंगे? देखेंगे. जो छोटा होगा वो रिजल्टेंट एरे में हम प्लेस करते चलेंगे. सो दिस इज द प्रोसेस. सो हियर 2, 5, 4, 7. which one will lesser? 2 is lesser. So we have put here again 4, 7 and 5. 2 लेसर होगा तो ये खत्म हो जाएगा. ठीक, अब इसमें एक ही एलिमेंट बचेगा. ठीक, अब 4, 5 and 7, तो विच वन विल लेसर? दिस वन. ओके, सो ये रिजल्टेंट में चला जाएगा. फिर 5 and 7, दिस वन लेसर, तो फिर ये चला जाएगा और ये यहाँ से खत्म हो जाएगा. तो ये बच गया, इसको सिंपली हम अपेंड कर देंगे. सिमिलरली यहाँ भी ऐसे ही करेंगे. तो लास्ट में, आई मीन सेकेंड लास्ट में, वी विल हैव ओनली 2 सब एरे एंड दैट 2 सब एरे विल बी सॉर्टेड सब एरे. सो अगेन one more time we will apply merging, means start comparing first element of subarray A with the first element of this. The value which will be lesser will be putting into the resultant subarray. So देखिए 2, 4, 5, 7 इनमें दोनों में कौन सा छोटा है? 1. ओके, B वाला, तो ये इसमें 1 आ जाएगा. ये यहाँ से खाली हो जाएगा, पॉइंटर यहाँ मूव कर जाएगा. 2, 2 इक्वल है, कोई भी आप रख सकते हैं. ठीक है, किसी भी ऑर्डर में. तो ये फिर खत्म हो जाएगा. देन 3, 6, 3 विल बी लेसर, ये खत्म हो जाएगा, ये रिजल्टेंट में चला जाएगा. 4, 5, 6, विच वन विल लेसर? 4. देन ये 4 इसमें चला जाएगा, ये खत्म होगा. 5, 6 एंड सो ऑन. सो वी विल गेट दिस सॉर्टेड. ओके, सो यूजिंग डिवाइड एंड कॉन्कर अप्रोच, व्हाट वी आर डूइंग? वी आर यूजिंग I mean recursion. Recursion means we are making a function like merge sort, and merge sort call itself merge sort, but जो उसके अंदर जो आर्गुमेंट पास कर रहा है वो क्या हो रहा है? वो चेंजेज हो रहा है. कैसे चेंजेज हो रहा है? क्यू, हम जो आर की वैल्यू हो रही है वो क्यू हो रही है फर्स्ट हाफ के लिए, एंड सेकेंड हाफ के लिए क्या होगा? Q+1 से स्टार्टिंग होगा. ओके, सो दिस इज ऑल अबाउट, आई मीन बाय यूजिंग divide and conquer approach. Merging already we have discussed with the, in starting we have discussed. Okay, same. This is the idea of merging, जो कि पहले ही आपको बताया. यहाँ से आप समझ सकते हैं. Suppose 2 piles of sorted card are here. So what we do? Choose the smaller of the 2 टॉप कार्ड. जो उसमें से टॉप कार्ड में से स्मॉलर होगा वी विल चूज. रिमूव इट, उसको रिमूव करिए एंड प्लेस इट इन द आउटपुट पाइल. रिपीट द प्रोसेस अंटिल 1 पाइल इज एम्प्टी. कब तक रिपीट करना है? जब तक दोनों में से कोई एक खाली ना हो जाए. जब खाली हो जाएगा तो क्या हो जाएगा? जो बचा हुआ है वो सिंपली अपेंड हो जाएगा. तो दिस इज द प्रोसेस एंड दिस इज द आइडिया ऑफ मर्जिंग, राइट? मर्ज एल्गोरिथम, आई मीन मर्जिंग ऑपरेशन, जो पहले भी मैंने बताया वही चीज इसमें किया गया है और कुछ नहीं किया गया है. अगेन वी आर कैलकुलेटिंग, बस ये क्या कर रहे हैं कि जो लिस्ट को हम L और R दो सब उसमें एक ले रहे हैं, मैंने सब एरे ले रहे हैं. ठीक है, हाफ इधर कर दिया लेफ्ट, आई मीन एक सब एरे में लेफ्ट वाला पोर्शन के आई मीन मिड पॉइंट तक, और R में क्या कर दिया? मिड पॉइंट के बाद वाले, जैसे 1 + 8 9, 9/2 4.5. तो 1 and 4 का एक बन गया, तो इसको L में रख लिया, और उसके बाद वाला यानी 5, 6, 7, 8 को R में हम लिख दिया. ठीक है, सो वी हैव 2 sorted array, and again what we are going to do, the value which will be lesser will be putting into the resultant. सेम वही जो पहले आपको बताया गया मर्जिंग का, राइट? So we can see from here. Now we just see what will be the time complexity of merge sort, means in terms of either recursion or anyway how we find the time complexity. So let's see the analysis. We have seen that a list has been divided into 2 parts. Okay, So we can write the recurrence relations like Tn, if we have Tn equal to 2 times Tn by 2, every time list gets divided into 2 half. So we can write like this, and we have 1 half and 1 half, n by 2 and n. So we can write that at every, horizontally, this will be the cost, right? Like suppose यदि n एलिमेंट है तो इसकी कॉस्ट n होगी, तो n by 2 में इधर किया गया, फिर n by 2 में इसकी भी कॉस्ट क्या होगी, n होगी. ओके, सिमिलरली इधर n by 2 का n by 4, इधर n by 4 में डिवाइड किया गया होगा. ओके, n by 4, इधर भी क्या हो गया, n by 4, n by 4 plus n by 4 plus n by 4 plus n by 4 times n by 4 means n. सो हॉरिजॉन्टली कॉस्ट क्या होगी इसकी, n होगी, एंड लास्ट में क्या हो जाएगा, 1 एलिमेंट है. तो इस तरह से हम इसका टाइम कॉम्प्लेक्सिटी निकाल सकते हैं, एंड रिकर्जन पे Tn इक्वल टू 2 टाइम्स Tn by 2 प्लस n. ओके, एंड लास्ट में जब एक एक एलिमेंट होंगे तो उसकी कॉस्ट क्या हो जाएगी, ith मान लो पोजीशन पे सपोज क्या हो रहा है, एक एक एलिमेंट हो रहा है, तो T1 इक्वल टू कांस्टेंट होगा 1, हमने यहाँ पे लिख दिया है. इसको जब आप सॉल्व करेंगे, सो how we solve, we just use the, either recursion tree you can use, or we can use just the substitution method. We will calculate Tn by 2 will be what, 2 Tn by 4 plus n by 2. Just replace n by 2, just replace n with n by 2. Okay, so we will get like this, Tn equal to 2 Tn by 2 means what, n के जगह पे आप क्या कर देंगे, n by 2 रख देंगे बस. ओके, तो यहाँ पे देखिए Tn by 2 की वैल्यू क्या होगा, 2 Tn by n के जगह पे, n by 2 की जगह पे क्या करेंगे, n by 2 by 2. n is n by 2. ओके, सो 2 Tn by 4 प्लस n by 2. इसी इक्वेशन में Tn by 2 को आप जब कैलकुलेट करेंगे, what will be Tn by 2, रिकर्जन सेम है. How will calculate, Tn by 2 कैसे कैलकुलेट करेंगे, इसी में आप वैल्यू रख देंगे. n के जगह पे आप क्या हो गया, n by 2, n के जगह पे क्या रख देंगे हम, n by 2. सो व्हाट विल गेट, 2 t, n के जगह पे n by 2 एंड डिवाइड बाई 2, मीन्स ये क्या हो जाएगा आपका, प्लस n by 2. We will simply replace n with n by 2. So we will get like this. So what we get, 2 t n by 4 plus n by 2. यही कर रहा है, ठीक, this one. Okay, 2 t n by 4 plus n by 2. So like this we will calculate. So this will be 4 t n by 4 plus 2n. Okay, 2 into n by 2, this will be n and n 2n. तो ये आपका एक इक्वेशन हो गया. सपोज ये फर्स्ट इक्वेशन है, Tn by 2 फर्दर ब्रेक 2 होगा, फिर आप Tn by 4 निकालेंगे तो n के जगह पे क्या रख देंगे, n by 4. सिमिलर ये n के जगह we will simply place n by 4, we will get this. So आप ये ऐसे ही निकालेंगे तो आपका ये आ जाएगा इक्वेशन 8 Tn by 8 plus 3n, right? So suppose at ith position what will be this. तो देखिए एक पैटर्न मिलता जा रहा है. सबसे पहले क्या है, फर्स्ट इक्वेशन में क्या है, 2 है, सेकंड में क्या है, 4 8, 2 4 8, देन क्या आएगा 16 एंड ऑल दैट. सो ith पोजीशन पे जहां एक एक एलिमेंट हो जाएगा वहां पे क्या होगा, 2 to the power i आप लिख सकते हैं, और सिमिलरली इधर डिनोमिनेटर में भी वही आ रहा है, यानी n by 2 to the power i. सपोज एट ith पोजीशन इट विल बी i t n by 2 to the power i. Not i, this is what, 2 to the power i, 2 4 8, यानी 2 to the power 1, 2 to the power 2, 2 to the power 3. Okay, so we can write Tn equal to like this. Suppose at kth position or even ith position we can write this recurrence like this, 2 to the power k, T n by 2 to the power k plus k into n. Every time we get n. So at kth level, ट्री की सपोज जो हाइट kth लेवल पे आप वर्टिकली जब जाएंगे, आप जैसे मान लो ये हो गया, ठीक है, सपोज लाइक दिस. सपोज ये 0 1 2, सपोज ये k है तो kth लेवल पे आप ये लिख सकते हैं 2 to power k t n by 2 to power k plus k into n. Every time we get n तो kth पोजीशन पे क्या होगा k into n. Okay, so how many elements will be there? Suppose n equal to 2 to the power k, so k we can calculate, k will be log n base 2. So if we will calculate, then we will get n log n plus n. So overall the time complexity of merge sort will be n log n plus n, which will be greater, n log n. So we can denote it as we can ignore this one, the value which will be lesser, okay, greater, so n log n. तो ओवरऑल टाइम कॉम्प्लेक्सिटी ऑफ मर्ज सॉर्ट विल बी n log n. बड़ा सिंपल है, ऐसा कुछ नहीं है. कैसे करेंगे हम? हर बार क्या है n by 2. ओके, सो n by 2 और आप यही काम देखिए बाइनरी सर्च में भी यही करते हैं आप. बाइनरी सर्च में क्या, बाइनरी सर्च में आप लिस्ट को हर बार 2 के डिवाइड करते हैं, ठीक है. सो n by 2 में उसकी टाइम कॉम्प्लेक्सिटी क्या होती है log n. एंड हर लेवल पे यहां आप देख रहे हैं कि n आ रहा है तो n log n ऐसे भी आप कैलकुलेट कर सकते हैं, राइट. सो दिस इज अबाउट मर्ज सॉर्ट. द टाइम कॉम्प्लेक्सिटी ऑफ मर्ज सॉर्ट विल बी नाउ n log n. ओके, सो दिस इज ऑल अबाउट. ओके, थैंक यू.